and listeners at home, my name is Phoebe Sukaiyayi, the Permanent Secretary, Minister of Education, Kaduna State. Welcome to Kaduna State Radio Television Program eLearning. During this period of coronavirus pandemic in our society today, it is our pleasure to introduce eLearning to our students at home, especially the SS3 students who are about to write their final exams. Therefore, we want to use this medium to ensure that our students are uninterrupted through their learning and teaching through this platform. Our listeners and viewers at home, it is our pleasure to ensure that this period we try as much as possible to bring the lessons that you are used to through our classrooms, through this medium, to ensure that you hold on to your platforms, you hold on to your lessons, to ensure that at the end of it all, you come out victorious. We are using this medium to ensure that we engage you, not only the student, but also their parents and their guidance, to ensure that, yes, Kaduna State is truly the learning center. Welcome to eLearning through the Ministry of Education, Kaduna State. Thank you for listening, and thank you for following up.
Good day, viewers at home. You are welcome to Kaduna State Ministry of Education Learning Program. My name is Hassan Buki. I'll be taking you physics. Now, the topic we will consider is conversion of galvanometer. A galvanometer is an instrument that is used to measure very little amount of current, and it is very sensitive. No matter how small the amount of current, it can detect it. The galvanometer can be converted to function as an ammeter and equally as a voltmeter. But for this lesson, we will only consider the conversion of galvanometer into an ammeter. So, conversion of galvanometer into an ammeter. The ammeter is an instrument used to measure large amount of current. So, the galvanometer can be converted to function in the same way as an ammeter. Now, to do that, we will need a shunt or a coil of low resistance value, which is called a shunt. And to convert the galvanometer into an ammeter, we will connect the shunt in parallel with the galvanometer. Now you may ask, why not a coil of high resistance, but a coil of low resistance? We know from electrical resistance that it is the ability of any electrical material to oppose or to resist the flow of current through it. So, if we have an electrical material with high resistance, which means it will only allow little amount of current to flow through it. But an electrical material with low resistance will allow large amount of current to flow through it. And the next thing you might ask, why not connect it in series but in parallel? As we know that when we have resistors connected in parallel, at the junction where their ends are connected, the main current flowing at that junction, the main current will be distributed to flow through the different components. And the amount of current that will flow through each component will depend on the resistance value of that component. So, at the junction where the galvanometer and the ammeter are connected, as the main current is coming, the amount of current that the galvanometer can only take will be the one that will flow through the galvanometer. Then that excess amount will be diverted to flow through the shunt, that coil of low resistance. And by so doing, the galvanometer will not be damaged, because we've already said that the galvanometer can take only little amount of current to flow through it. So whenever you allow a large amount of current to flow through the galvanometer, it will be damaged. So whenever you are faced with a problem, supposing you are given a galvanometer and asked to convert it to act as an ammeter, you will need to know the resistance value of the shunt that will be suitable for that particular galvanometer. And therefore, for you to know the value of the shunt that will be suitable, you need to calculate and get the resistance value of the shunt. So the conversion of galvanometer to ammeter. Here we have the circuit diagram showing the parallel connection between the shunt and the galvanometer. We have I, which is the total current in the circuit. I subscript G shows the current flowing through the galvanometer, and R subscript small g is the resistance of the galvanometer, while I subscript S is the current flowing through the shunt, and then R subscript S is the resistance of the shunt. So now we will now see the derivation of the formula that we could use to calculate the resistance of the shunt. Here we have I to be equal to I subscript S plus I subscript G, which means the total current flowing in the circuit is equal to the summation of the current flowing through the shunt and the current flowing through the galvanometer. Now for resistors connected in parallel, we know that the potential difference, which is PD across their ends, is the same for all of them. Therefore, the PD across galvanometer, which is V subscript G, is equal to the PD across the shunt, which is V subscript S. Therefore, VG is equal to VS. And we know from Ohm's law that V is equal to IR, which means the potential difference is directly proportional to the amount of current flowing through an electrical material. Now, following from Ohm's law, Vg, which is the potential difference across the galvanometer, will be equals to I subscript G times R subscript G, which means the current flowing through the galvanometer times the current flowing through, times the resistance of the galvanometer. And also Vs will be equals to I subscript S times R subscript S, which is the current flowing through the shunt times the resistance of the shunt. Now, if we substitute equation 3 and 4 into equation 2, we will now have IGRG to be equals to ISRS, giving us equation 5. Now, from equation 5, applying change of formula of subject of formula in mathematics to make RS the subject of the formula, we will now arrive at RS to be equals to IGRG all divided by IS. So with this formula, we can determine the resistance of any shunt that can be used to convert any galvanometer into an ammeter. Now we will take an example to see. Example, the question says, a galvanometer of resistance 5 ohms gives full-scale deflection of 15 milliampere, which is to be used to measure current of 1.5 ampere. Determine the resistance of the shunt. Now, what this question is asking us to do is this. We have been given a galvanometer. We know the amount of current that the galvanometer can take to be 15 milliampere. The resistance of the galvanometer is 5 ohms. Now, we are to convert this particular galvanometer to function as an ammeter. So, just like I've said before, we need to calculate and get the correct shunt that can be suitable for use to convert this particular galvanometer into an ammeter. So we have the diagram for the solution of the above question. So we have our equation I is equals to IS plus IG. So IS, making IS the subject of the formula, we will have IS to be equals to I minus IG. Substituting our values, we will have IS to be equals to 1.5 minus 0.015. That will give us 1.485 ampere, which means that the current that will flow through the shunt is 1.485 ampere. Now, applying our formula for shunt resistance, RS is equals to IGRG all over IS. Substituting our values, we will have RS to be equals to 0.015 times 5 divided by 1.485, which will give us RS to be equals to 0.05 ohms, which means that supposing we are given a number of shunts and we are asked to convert this particular galvanometer to an ammeter, you can't just pick any of the shunts. You have to calculate. Now that we have gotten our value, we will now look at which of the shunt has the resistance value of 0.05 ohms. Then we connect in parallel to the galvanometer and it will function just like an ammeter. So, with this, before I go, I will want you to remember, take note of 3 important things that has to do with conversion of galvanometer into an ammeter in case you come across any question concerning conversion of galvanometer into an ammeter. First, remember that a coil of low resistance is used and the connection is parallel connection, not series. Now again, you have to remember that the total current flowing in the circuit is equals to the current flowing through the shunt plus the current flowing through the galvanometer. Again, remember your Ohm's law. The next thing is, remember that the potential difference across the galvanometer is the same as the potential difference across the shunt. If you can remember these things, no matter what you are looking for, you are asked to calculate in any question that has to do with conversion of galvanometer to an ammeter, with your knowledge of mathematics, you can do it. Thank you for viewing. I will now call on my colleague, Mr. Napoleon Kure, to come and review the lesson.
Good afternoon, dear viewers. I'm Napoleon Kure by name. Well, I'm here to talk on a topic in physics, galvanometer conversion to ammeter, on Kaduna State program that have been scheduled on radio, television program, eLearning. And as my first colleague has done justice to the topic on conversion of galvanometer to ammeter, the definition of the terms have been made. A galvanometer is an instrument for measuring a very small amount of current, which is has a current measured in ampere, and an ammeter, on the other hand, is a device or an instrument that measures a large amount of current. So actually the conversion is the value of current passing through the galvanometer will determine the resistance of the galvanometer, and an instrument known as a shunt, a very small coil that has low resistance, and allows a lot of current to pass through it. That is what we do in the conversion. And in the conversion, we have the galvanometer has certain values it allows, of a value of current it allows by virtue of its resistance, while the ammeter also have the amount of current which is determined by the resistance it offers to the current. As he rightly said, this is done by parallel connection of both the galvanometer and the ammeter and the shunt, as you have been seeing. And worthy of note to take this, that because current is a vector quantity, we see that arrows are indicated on the lines that are there. Otherwise, it's not current. So we see arrows pointing the direction of the flow. The main current passing through the circuit is letter I, while the one passing through the galvanometer is letter IG, and for the shunt, current is IS. Where you have the resistance through the resistance of the galvanometer is RG, that of the shunt is RS. Now, in the derivation of the formula, we have the total current flowing through the circuit is a sum of the current through both the the galvanometer and the shunt. Where you have any parallel connection, as many devices you are connecting in parallel, the potential difference across each of them is equal or the same. And so we see the potential difference across the ends of the galvanometer, VG, is the same as that across the shunt. That's why we have the equality of VG with SVS. But then applying Ohm's law, we say that any current passing through a metallic conductor is always, directly proportional to the potential difference connected across it. Metallic conductor, which is the only type of conductor that this Ohm's law is applied to. And so, with the derivation V is equal to IR, which is the Ohm's law, our VG, which is the potential difference across the galvanometer, will be equal to the product of the current and the resistance across both the galvanometer as well. The same thing is applicable to the shunt, that the potential difference of the shunt is the same as the product of the shunt, of the current passing to the shunt and the resistance of the shunt. Applying the equation 3 and 4 into 2, we have the equality of IG, RG equal to IS, RS. And making the subject of the formula for RS, we have it equal to IG, RG over IS. With this, I suppose that the students have had a better understanding on conversion of galvanometer to ammeter. Thank you very much.
Good day, learners. I am Anthony Yakubu Gankon. I'm here to present to you the assignment based on the topic conversion of galvanometer into ammeter. My colleagues have earlier made justice to the topic conversion of galvanometer into an ammeter. And both of them have put everything into a good perspective for you to follow. I hereby want to present the assignment to you, which you will be able to attempt at home and see that if you have followed the topic very well. The assignment is as follows, or as follows. Number 1, a galvanometer has a resistance of 5 ohm. By using a shunt wire of resistance 0.05 ohm, the galvanometer could be converted to an ammeter capable of reading 2 ampere. What is the current through the galvanometer? Question 2. A galvanometer has a resistance of 5 ohm and a full-scale deflection of 2 milliampere is to be used to measure current up to 2 ampere. What shunt will be suitable for use? I think with this assignment on ground, you learners will be able, as you attempt them, putting all the knowledge acquired from my colleagues, you will be able to answer any question, but either in WAEC or NECO, whatever examination, to the best of your ability. So thank you.